Alright, this particular chi-square problem involves corn. And corn has different phenotypes. There's purple and there's yellow seeds. Purple is dominant, yellow is recessive. And then there is the structure. There's smooth, fat kernels of corn, and there's shriveled kernels of corn. So this image is on the problem. The picture is on the set of problems. I just wanted to give you a color image of what the corn looks like. So you've got these purple corns, which is dominant, over yellow color, and the smooth corn is dominant over the shriveled corn. And let's go here to the actual problem. Okay, so here we have purple kernels are dominant over yellow, smooth kernels is dominant over shrunken. We did a test cross between corn that was heterozygous for both traits. So heterozygous for purple kernels and heterozygous for smooth kernels. We looked at the offspring from the F2 generation, and we looked at one cob. In that cob, we counted 381 kernels. Out of those kernels, we found 216 that were purple smooth. This is dominant. So this is dominant D and dominant G. We found 79 that were purple shrunken, so they're purple, but they are shrunken, like shriveled. We found 65 that were yellow smooth, so this would be little d, because that's recessive, but they were not shrunken, they're smooth, plump, fat kernels. And then we have 21 that are yellow, little d, and shrunken, little g. So that's our data. So we're about to do a chi-square to see if our data gives us acceptable data. We can repeat our experiment and see if it's acceptable in the statistical world. All right, so first, what is our expected ratio of corn kernel phenotypes? Well, we cross heterozygous times heterozygous, and we know we should expect a 9, 3, 3, 1 ratio. 9 should be dominant. That's the purple smooth. 3 should be dominant recessive. That's a purple wrinkle. 3 should be recessive dominant. That's the yellow smooth. And this 1 should be recessive. Okay, so out of 16, 9/16, 3/16, and 1/16. So, what are our expected values is our next task. We have 381 total kernels. Well, we expect 1/6 to be yellow shrunken. So, what is 1/6 of 381? 381 divided by 16 is 2381. So, let's round that up to 24. So, we expect 24 to be yellow and shrunken. Well, how many is 3/16 of that? Well, just take 24 times 3, 72. So we would expect 72 to be purple shrunken and 72 to be yellow smooth. All right, so how many do we expect to be purple smooth? Well, one more time. We take 24, because that's 1/16, times 9. So we want 9/16, and we get 2/16. So all of these are the expected values. This is 9/16 times 381. This is 3/16 times 381. And this is 1/16 times 381. All right, so now we have our expected values. We can do our chi-square. Observed What did we observe? We observed 216. 216 minus 216 squared divided by 216. Well, that should be pretty easy. 216, so that's 0 squared divided by 216. Oh, that's easy. That's 0. All right, next we have 79. So we observed 79. We expected 72 divided by 72. Plug that in. 79 divided by 70. Oh, sorry. 79 minus 72. X squared divided by 72 gives us this value, so we'll just make that 0.681. 0.681. Okay. Plus, what is our next observed value? Our next observed value is 65 minus 72 squared divided by 72. 65 minus 72 equals squared divided by 72. Same answer, 0.681. And finally, we observed 21, yellow shrunken. We expected 24, square that, divided by 24. So, on 21 minus 24, x squared, divided by 24, gives me 0.375, so plus 0.375. So, clear, 0 plus 0.681 plus 0.681 plus 0.375 is, so our chi-square value is 1.737. Chi-square, 1.737. All right. So there's our chi-square. How many degrees of freedom? Well, how many options do we have? We have 4 options. Minus 1 is 3. So there's 3 degrees of freedom. So we're going to take this value, the chi-square value, and the degrees of freedom, apply it to our table. We are looking at the third row because we have 3 degrees of freedom, and we are looking for 1.737. So 1.737, 2 is here, 1 is here. So our p-value is somewhere between 0.5. So this is our chi-square value. Our chi-square value is somewhere between 2.3 and 1.2. So the equivalent p-value is between 0.5 and 0.75. So using that, so it's between 0.75 and 0.5. P is smaller than 0.75, but it's bigger than 0.5. Okay. Is the deviation from this data within acceptable limits? Well, yes, it is. Why? Because here, our p-value is over here. Anything on this side is acceptable. So the answer is yes. So what is this saying? This is saying this, we didn't get exactly what we expected. We expected 72, we got 79. Expected 72, got 65. Expected 24, got 21. We did not get exactly what we expected. But the deviation is within acceptable limits. So whatever happened just out of chance. And I hope that's helpful.